Alright, so today I'm going to be solving a very basic derivative problem in Calculus 1 by using first principles. And basically I'm just going to be finding the derivative of a function, and then I'm going to be applying it to a certain situation with a parabola. So that's what I'm going to do today, and it's pretty cool. So, alright, so say that we have the function f of x is equal to 2x squared plus 4x plus 6. So say that you have to find the derivative of this function. So if you're taking calculus 1, then you've probably already seen first principles. This is just to help you put it more into practice. You might have also seen the power rule, which is usually what you see after you see first principles. But by using the power rule, you would already know that the derivative of this function would be, well, this 2 over here this 2 over here multiplied with this 2 over here minus 1, so this would become 4x, and this 4x 1, you would multiply this 1 over here with the 4 over here and then do minus 1, so that would be 4x to the 0, which is just 4 times 1, which is just 4, and then the coefficient you would just take it out. So this would be your derivative. However, I'm going to be doing it by using first principles. So here we go. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And now every time I'm going to be writing this again and again, I'm always going to remember to write the limit as h approaches 0 until I actually evaluate the function at h is equal to 0. It's very important because you could actually lose points for not writing it, because if you forget it, it's sort of like, well, it's just not a good mistake to make. So anyways, now that I have this, my first principles written down, what I'm going to do is I'm going to start replacing my function into this thing over here, and let's get started. So this is going to be the limit as h approaches 0 of, and I'm going to replace x plus h in every x that I have in this function over here. I'm going to rewrite it over here because I kind of made it dirty over here, but it's 2x squared plus 4x plus 6. So this becomes 2x plus h squared plus 4x plus h plus 6 minus, in parentheses, 2x squared f of x, so 2x squared plus 4x plus 6, all divided by h. Now we still can't really evaluate the function at h is equal to 0 yet, well, obviously, because if we did, then we would just be dividing everything by 0, since we have h in we still have h in the denominator over here, in the denominator over here. So we're just gonna have to keep developing this whole thing and factorizing to try to get h out of the denominator over here, and then we'll be able to evaluate it. All right, so let's continue. This is equal to the limit, and don't forget to write it every single time, the limit as h approaches 0 of, now I'm going to be developing this is 2, and then in parentheses x plus h squared is x squared plus 2xh plus h squared. You have to remember your 10th and 11th grade factorization methods. So this is, I don't know what you call it in English, but this is just basic factorization, basically from high school. Plus 4, now I'm just going to be distributing the 4 over here, plus 4x plus 4h plus 6, and I'm just going to keep writing it over. Actually, I can still write it. Alright, now I have minus this whole thing, which makes the minus sign distribute itself into each term, which means that everything here will become negative. So this is going to be minus 2x squared minus 4x minus 6, and all this is going to be over h. Next, I have the limit as h approaches 0, and I'm going to be distributing my 2 over here. This is going to be 2x squared plus 2 times 2xh, which is 4xh, plus 2 times h squared, which is 2h squared, and then plus everything else. all this divided by h. Okay, so before I even continue, I can already see that I have a few terms that I can cancel out because I have, like for example, I have this 2x squared over here, and I have negative 2x squared, which means that they just cancel each other out. So I can take this out and this out. Next, I have 4x positive and negative 4x. I can cancel these out. I have 6 positive and negative 6, so I can cancel these out. And all I'm left with is the limit as h approaches 0 of 4xh plus 2h squared plus 4h all over h. Now we have h in every single term that we have over here, so we can factorize it, and then eventually by factoring out an h from this like expression, we could divide it with we could divide it with this h over here, and then get it out of the denominator, which is going to help us evaluate the function. So that's what I'm going to do. I'm going to basically factor out an h over here on the numerator. So this is going to become the limit as h approaches 0 of h. This becomes 4x plus 2h plus 4 all over h. And when you look at that, I can take this out and this out because they cancel each other out. This becomes the limit as h approaches 0 of 4x plus 2h plus 4. And now we can finally evaluate our function at h is equal to 0 without having any weird 0 over 0 indeterminate forms or anything of that sort. So this becomes, and now you don't have to write the limit as h approaches 0 anymore, because now you're actually evaluating the function at h is equal to 0. So let's do that. 4x plus 2 times 0, because it's 2 times h, plus 4. This becomes 0. So this becomes 4x plus 4. And that is the derivative function of our, well, original function, as we also proved earlier with the power rule. 4x plus 4.